and address. You can serve it via a dedicated service. It really depends on how you want to do it. The model can also be published as data, so you can apply data streaming, or you can do offline prediction, so with batch prediction. For the embedded application, what we do here is we ingest the model at build time, okay? Because the model now is a dependency of our application, and the model is packaged within the actual application itself that's using it, right? So here we need a pre-trained model. We can apply predictions on the fly. For the other one, where we dedicate a model API, the model now is not part of our application, but rather it's outside it, and it's serviced by some form of API where the model can use it when needed. Okay, whenever it's needed, the model can use it, or the application can use that model. Today is a bit of like mixture of the two, really. Okay, what's important for me today is to show you how, after you have packaged up your model, how you can correctly create an API for it, so that API can be deployed and can be used as a service. Okay. And then how to consume the model? Well, people can use mobile devices. It can be used into the Internet of Things. It can be used via web browsers. It can be used via HTTP clients, such as even command line tools, or even programmatically. So if you're a Python developer or Python user, we have a very nice package called the requests package, and that's a package you can use in order to communicate with the API, send the data, and then get back results. Now, within Python, we have really powerful web frameworks that provide tools to handle and automate standard tasks when we build web applications. So we want something like, for example, session management, or maybe templating, or database access, and so on. There are more than one platform to do, one framework to do that. In Python, we have Flask, Django, and then not too long ago, FastAPI. Okay, this data is a bit outdated now, but because Flask is the oldest of them, it was launched back in 2011. Perhaps it is the most commonly used web framework. After it, we also have Django, which is really powerful. And not long ago, we now have, or FastAPI was born back in 2019. FastAPI is a highly useful package in Python. I think, if I'm not mistaken, it actually won the best Python package of the year back in 2019, if I remember correctly. So FastAPI is one of what we're going to be using today. I'm hoping that you are familiar with Flask and Django when you create an API, so that you can see FastAPI will save you a lot of the pain. Okay, will help you avoid a lot of the pain that you go through when you use Flask and Django. Now, FastAPI, as the name says, it's really fast, and it helps you use Python's async capabilities. It helps you apply validation on the fly. Remember, we spoke about type hints and pedantic or pydantic in the first session. FastAPI uses them as well. It gives you automatic documentation, and it also helps you with dependency resolution. Dependency resolution is a hard problem usually. FastAPI makes it really easy to avoid that pain. Okay? So before going into the web server we're going to be using, let's dig deeper into FastAPI. Okay? So you can look at in the theme, the features, like for example, Python types. We're going to have a look at the tutorial. Let's see. So it's fast to code, less bugs, quite intuitive, easy. It's really nice. Okay, and who's sponsoring it, who's using it. Let's see if we find an example where we can copy paste. So you can install FastAPI, and then you will need UV Core to work with it so you can serve it. Okay, so you can serve the API via this web server called. In fact, let's speak about UV Core quickly because they work nicely hand in hand. So, you have a link? No, not yet. Okay, so UV Core is the asynchronous server gateway interface. Okay, so UV Core is an implementation of the ASGI interface. If you are familiar with this stuff, okay, using Python async IO libraries and so on. Okay, but let's actually have a look at UV Core. Where is that link? That's FastAPI. We're done with docs. So if you search UV Core, see now you can see immediately that it's very good friends with FastAPI. They work really nicely hand in hand. This is a web server implementation for Python. Okay. And that's how you install it. Okay, if you will to install a specific version, it's fine. Otherwise, you can do pip install UV Core. That's for the web server. And then FastAPI, you can say pip install FastAPI. So let's actually, okay, for using endpoints using FastAPI. So I'm gonna copy this code, and then I'm going to perhaps, okay. So let me go. I just want to demonstrate this, and then we'll do our own stuff. Okay. So I'm gonna say make the FastAPI. I call it FastAPI. CD into FastAPI, and then I'm gonna say cat main.py, not cat, sorry, not cat, nano, simple text editor, paste the code. What the code is doing is this. It uses the Python typing package, okay, and then it uses FastAPI, import FastAPI, and then it creates an app. And then here, it creates two endpoints. Okay, so the one at the slash, which is the root, and it see in the function name, so this is a Python function decorator, app.get, at the slash, meaning at the root of our web page, we'll only see hello world. It will return this dictionary saying hello world. And then if you go slash items, then what it will see now, it uses a function called read item, and then you have the item ID that's integer, and there's something called queue, which can be a union of either string or none. So it can be empty or a string. So item ID and then the queue. Okay? Is that the correct code? The answer is yes. Let's save it. We also have two endpoints, okay? Now, what we'll do is we'll call UV Core and then run main app and then load it. Let's go. Okay, it works on port 8000 by default. Okay, application startup complete. So if I go now, copy this, I go to my web browser, for example, paste it here, and now I can see the hello world message. Okay, that means the web server is working, my API is working. And now if we look at the documentation, it says if you go slash items and then pass it 5, okay, and then Q is for like some query, then it'll say, yeah, the item ID is 5, and then the query Q is some query. Notice here in the type hints, we said, okay, item ID is integer, it means it's required, and then the Q can be either string or none. So this is where we use Python typing. It can be either string or none. And the nice thing here is that when we specify the type string, even if we pass something that's not a string, it can actually throw an error, it can complain. So let me copy this, and I'll paste it here. Please pay attention. So it's the localhost colon 8000 and now /items/5, and then the queue is some query. Hit enter, and it gives you back the result. Imagine now you're passing data. Imagine you're passing data to your Python code, and your Python code is doing something with that data. That's the idea of the API. Okay? And we mentioned it's so powerful. This is because if we go /docs, it gives you automatic documentation. If any of you is familiar with Swagger, okay, this is now obtained for free with FastAPI. If anyone familiar with Swagger at all, Swagger API. See, this is the API documentation and so on, and blah, blah, blah. It can be quite complex. It can be a real pain to go through it. This is, and by the way, now it's known as the Open API. This is built in within FastAPI, so we don't have to pay a lot of attention to it. Okay? And this is saying that by using this sample code, you've already created an API. It receives HTTP request via the /or/items. Okay? They use get operations. Okay? It has a parameter called item ID and optional parameter Q. This is the /items which we defined here. Yeah? Parameter item ID, optional parameter the Q. So if you look at the docs, like we said before, this is automatic interactive API documentation provided by Swagger UI. This is obtained for free. It's built in within FastAPI. And trust me, if you've not used Swagger before with other projects, I've been through it. It can take some time to configure it correctly. The beautiful thing about FastAPI is that it comes already for free for us. Okay, and then you can, for example, this is a bit more complex sort of application, so you can have a look at it. This is the root endpoint, and here now we're using models. So now we are basically describing our data using models. Okay, so we are saying, for example, that our item should have a name of type string, price of type float, and then is offer of type sort of Boolean, either true or false or none. It's optional. Okay, so this one here, for example, update item, and then item name, item ID, and so on. Whereas this one just items to read items. Okay, like we said, you can now go down and have a look at more complex examples. I leave that to you to study in your own time. If I go back to the API, see, now you can actually click on these endpoints and see what's going on. You can, for example, try them. So you can, for example, pass some data. Let's say, for example, see the item ID is of type integer. So I'm going to say, for example, 900. The query is optional. I'm going to say, for example, test. So I'm going to say execute. Yeah. We get a response 200. So everything is working nicely. And that's the response body. Okay. It returned what item ID and the Q test. This is exactly what was specified in the Python code. That function returns what? It returns the item ID and the query. Remember, the query is optional. Let's test a bit more, okay? Please pay attention. So now, I'm going to say, for example, I'll leave this empty. Test is optional. So execute. I go down, and I get Q is null because optional. The response is 200. Now pay attention to the fact that in the documentation, we are saying the item ID should be an integer, which means if I was to pass it a floating number or a string, maybe, I'm going to say, for example, string, the word string, for example, or maybe it can be confused. So say, for example, London, and then execute. See what this is doing. Say no, error, I can't accept because this is meant to be of type string, integer. See? This is why, if you remember, we mentioned doing type checking for us on the fly and validation and so on. This is all obtained for free with FastAPI. You don't have to write your own validation in the code. In fact, as we will see in the example, we can actually specify our own schemas. If you remember, the entry schema, the Titanic row schema we looked at in the previous session, we will take advantage of that in when we create the API. So if I take you back here, and second, let's see where I have the schema. No, not here. Anybody remembers where we had the schemas? Or not in the config. No. Anyone remembers where we had the schemas? Come on, anyone? Validation. Yeah, there. So this is the schema, and this is basically based on Pedantic again. This is the schema of a Titanic data input. So this is one row from the Titanic set. And we mentioned that multiple Titanic data inputs, this is when we pass multiple rows. So this is basically a list of this. Yeah? We can take advantage of this schema to tell FastAPI, do the validation of the data on the fly for us, meaning only accept data that adheres to this schema. Although we're saying optional here. Optional means it can be provided or not. So perhaps if we want something to definitely exist in the data, then we can avoid using optional, for example. Yeah, I wanted to read more about typing and Pedantic and how it works, how you can use them together, use the base model, and then use the types here to specify what the input should look like. And this will save you a lot of data validation. Trust me. You do it only once, it'll save you a lot of pain when it comes to data validation. So now see it's refusing to actually do that. Okay? So let me, in fact, because we do have a bit of time, let me quickly go down to this little bit advanced example, because now we are using base model from Pedantic, and then we're saying this is what the item should look like. So it should contain these three fields. The name and price are a must, whereas is offer, it can be either Boolean or none. The default is none. Okay? Or perhaps I can leave this to you if you wish to experiment with it. Okay? In fact, let's leave it here. We'll come back to it if we have some time. All right. So now after we've clarified this, again, any questions, please send them through. Now we have clarified this, UV call and FastAPI. Let's go to our code. Okay? And now you have all the code, remember, on the GitHub. And now instead of using the classification model, because now we have created the package and we have uploaded it to PyPy, let me go to Titanic API. This is where we actually create the API. Okay? So again, we're going to be using Tox here as well. And for Tox, let me zoom in a bit. Again, you can use my stuff and build on it. You don't have to write this from zero. The default environment is what? Test the app, apply type checks, style checks, and linting. And then, so for example, this is to apply testing. This is where you install the requirements. And then you basically apply PyTest. Okay? Because we have a folder called tests under the folder called app. There we can write our own tests. And then to run the environment internally, I'm just running Python, the main.py file. We'll come to it, okay? We'll come to it and see what it looks like. And then to apply type checks, remember MyPy, we'll run MyPy. To apply style checks, we'll apply Flake 8. we'll apply linting, we'll apply what isort, and then black. Okay, and this is a configuration for Flake 8, what to exclude, and then, for example, the maximum line length. So if your line is more than 88 characters, it will basically push it into a new line. Okay, so we'll be using talks again, and these are our test requirements. So the version of PyTest, the requests package, the black package, Flake 8 package, the MyPy package, and the isort package. Now, and it also at the top, if you see, it does call the requirements file, which looks like this. UV-corn version, between this version and this version, FastAPI version, and some pedantic typing, Logoroo for logging, and they see the Titanic survival model version 0.0.10, the one we have uploaded earlier. You remember, it didn't upload for me because I've already done it this morning, but that version of the Titanic survival model, because now it's in the requirements file, meaning Tox will install it on the fly for me. And it'll be part of my API. It'll install the model for me. Okay? So I'll come back later on to, for example, to the runtime. Here I'm specifying the Python version I want to be using. I'll come back to this script and to the Docker file. I'll come back to them later on. Let's continue. This is MyPy configuration, for example, what to use. So we're going to use using pedantic and MyPy. And this file is just to specify some configuration for UV-core. You see, it takes the port number as an environment variable. Okay, we'll come to it as we progress. So let's have a look at our app, our API, and see what it looks like. Let's begin with, what do we begin with? The main or the API? Let's begin with the main file. Okay, so let me zoom in a little bit. And this is a bit advanced, like we mentioned before. Here we're doing some imports, so apply all or any types from the package typing. From FastAPI, I import API route, the FastAPI and request. Again, import this middleware stuff and import HTML response. Now, we used the Python logger before, and now we're going to be using Logoroo. It's much more powerful than the default Python logger. Okay, it helps you obtain logs at a lower level, basically. And here, you can set up app logging. We'll have a look at the configuration. Okay, we'll have a look at what the config settings looks like. And now we start to create the FastAPI app. So this is similar to what we've seen here. Okay, start the API app, but with a bit more configuration. Okay, for example, from the settings, you can get it the project name. You can also get it the open API URL, and then you create an API router, and now you start to create your endpoints. So this is what we call the home endpoint. Okay, the slash. And now see, now we're using the router.get, and this is saying, okay, and when you land on this page, I want you to display this HTML stuff, and then return HTML response so that it's displayed on the browser. So what we do here is, it has an input request, and then we define the response body and return it as HTML response. This is type hints. In Python, using typing, any type, it can be anything. And now, let's specify more complex API endpoints that we can use to, for example, make predictions and so on. Okay? So, basically what we do here is, we can specify these complex endpoints using the include router method. Okay? And later on, when we have a look at what the actual API looks like, this will all make sense. Okay? But you can leave this as default, okay, if you find it advanced, or if you're not familiar with the coarse middleware stuff, just leave it like that, and it'll make sense when you use it a couple of times. And here in the main, we just basically run the API. So we import UV core and then run it. See, we run it or import 8001. Okay? And now, as you can see, because we're logging via Logoroo, we can actually specify the logging level even. This is really powerful because logging in Logoroo is really powerful. Let me show you what this means. You might not be familiar with Logoroo. Excuse me. So this is really powerful logging. You can read about it and what it looks like. Let me show you the actual levels. I want to show you the actual levels of Logoroo. So features, for example. Let's see if we find the levels here. Customizable levels. Where do we find levels? No. I want to show you that you can customize logging to different levels. Hang on a second. Let me say Logoroo levels. Where do you find levels? Yeah, there you go. So you can customize or the logging level into, for example, really low level or for debugging information. And this is hierarchical, okay? So it means that when you have this level, it automatically includes the levels under it, okay? So for example, you do trace, you get everything, you do debug, you go debug, and the one below it, and so on, okay, depending on the severity value. Okay, this is really powerful. You don't get this much into the default logging in Python. You can write it as debug there, okay? The log level is debug, which is here. Logger.debug. Okay? Okay, so if we look at the API, so this is where we have all the details, okay? So for example, we have a health endpoint, okay? It's under /health, okay? And it responds by returning the health schema. The status code by default is 200, okay? And what it does, it defines a response schema, and then it returns it as a dictionary, okay? On the fly, FastAPI will convert into JSON, because JSON is the communication standard here. That is for checking the health. We'll have a look at the schema soon. Okay? The other endpoint here is the predict endpoint. So this is the endpoint that gets the data. It uses the model to make predictions and then send back the results. Remember the results I explained in the previous session. The results will be what will be a dictionary where it has the predictions, the model version, and if there are any errors. So we'll focus on the predictions field later on. But what happens here is the following, and this is using Python async, okay? What this is saying is the input data should follow the schema. Remember the schema, the multiple Titanic data inputs? That's why the data schema is useful. If you do this, it'll do the type checking automatically for you. And this will save you a lot of pain for data validation. Yeah? What it does is the following. Because the data comes in JSON format, so we encode it, we grab it, we create a data frame out of it. You can apply some logging if you want. And then you can call the make predictions, the make prediction function from the package. See what we're doing here. Hang on a second. Yeah, because we've installed the package. Remember the Titanic survival model package? We uploaded to PyPy. Now it will be installed automatically for us here, version 0.0.1. This function is coming from that package. Okay? We send it our input data, and it gives us back the results. Remember, the results is a dictionary. If there are no errors, then fine. Otherwise, we'll raise an exception. If the data has an error, if the predictions have errors, or there's an error with the predictions, we'll raise an error, and the status code will become 400. So something is not right. Otherwise, we'll return the results. So if we have no errors, we'll return the results in the format specified in the response model. And now we have Pedantic and FastAPI working together. Okay? So this is very important to understand, okay, how this is structured. Now let's have a look at schemas. In the schemas, for the health, to check the health of our API, you have a simple class called health, the name of the API, the API version, and the model version. Just 3 strings. Okay, this is for the health. Now for prediction, remember from the Titanic model, we do have the Titanic input schema, if you remember that. You remember that? That's it. Now the prediction results will contain what? Remember 3 fields? We said it's a dictionary. Here, you model it by a class. So the schema will look like what? If there are any errors, that's 1 field. The version, it's a string, and it's a list of predictions. Each value can be a float. Okay? And now this is the multiple Titanic inputs, which is a list of the Titanic data input schema. Okay, very similar to what we had in the actual package. And now here under this class, we can have a subclass where we provide example data. Okay, we call this schema extra. And here we're able to provide an example with dummy values. Okay, just when we load the API, it comes automatically with these values by default, so we can apply some testing. So we can try this out in our documentation. FastAPI picks up inputs and the response model of different endpoints. Based on that and little config, we get documentation out of the box. Okay, this is really good stuff. So this data schema, this JSON object, will appear in the API documentation. That's the purpose of it. If we could have stopped here by saying, oh, the data should follow this schema, or we're providing this as an example. Okay, so this is the predict schema and the health schema. We saw the main API, we saw the API.py. Let's have a look at the configuration. And now in the configuration, again, somebody might look a bit advanced, but this is basically just, for example, configuration for logging. Okay, remember it's hierarchical. Apply some settings. Okay, for example, the API version 1, and some sort of port numbers to try and ignore. Oh, is the stuff case sensitive? Yes or no, or true or false? This stuff is from Logoro. Okay, this is a bit advanced. This helps you intercept logs at a very low level. Okay, so I have to say that even if you don't understand this stuff, it's fine. Okay, this is copied and pasted from the documentation of Logoro, and this is the link. Okay, so you can copy this link, paste it into the browser, and you'll find the Logoro explanation of why that's useful. Okay. And this is now the settings object that will get exported. If you remember, somewhere here, we extracted data from something called settings, and you might have wondered where the setting comes from. Okay, it's that object that has all the settings. Excuse me. And that way, now our API is ready. What's very important here is to configure talks correctly, to prepare the requirements correctly. So your required packages, especially your model, what it's called when you import it. You might have seen Titanic model. That's when you import it. It's called Titanic model. That was a configuration when we configured the actual package earlier on. Once you install Titanic survival model, when you import it, you import as import Titanic _ model. Okay, that's one of the configurations there. And then you can follow my way of preparing the schemas for the health, for example, to show different versions, to predict, which is basically using the schema from the actual model itself. And then when you make the predictions, how you can actually call the make prediction function, which is now inside the Titanic model. See, that's what we're importing here. Remember, Titanic model.predict import make prediction. The function was under the Python script called predict. You can also import the version from there. Right? Having done this, if you've reached this far, again, I'm happy to repeat anything here as long as you want to really understand how it works. Because like I said, some of you might find this a bit advanced, but if you do it this way, then your API now is good to go. Okay? We can start the API manually, or we can use our friend Tox. So going back to Tox, okay, one of my environments here, okay, you can apply testing, like pipe checks, style checks, linting, and so on. And please do remember that Tox, because Tox creates a virtual environment, let me clear the screen, cd into the actual API, which is using the model from before. So cd into it. If I show you Tox folder, the size of it is what? Is nearly 0.5 GB. Now, when you run this stuff for the very first time, it'll take a bit of time. It'll take a bit long because it'll do a lot of downloads, a lot of installations. I have already run it this morning, save some time in the live course now, and therefore, if I do Tox, it'll be really fast. But before we do that, though, let's go to testing. So let's go to testing. Where's the test folder? There you go. So let's have a look. This is similar to what we've seen before, using PyTest, okay? Similar to what we've seen before, using PyTest and using the fixtures, okay? So these are the fixtures. One called test data, very similar to what we've done before. It's the same thing as the test size, the target variable name, the random state, so it'll give you the same result as before inside the actual package, and then return the X test data. And then this one here will create a client so that the FastAPI client can make calls. This can make API calls. Basically, what this is saying is, when the API is running, we can use this client to communicate with it. Please, you can write this if you're taking notes. You can ignore this and use the beautiful Python package called requests, because via requests you can communicate with the API really easily. Okay, so these are this is the fixture to create the data. The actual test is done here. Okay, so imagine the API is running. If the API is already running, okay, we'll get the test data from the previous fixture from here. Okay, and we'll get the actual client from the test client. Sorry, we get the test client from the client, and then that client is going to communicate with the API. Remember, we can use the request package Python. And now what we do is we prepare the payload, so we'll get the data. If we have any NaN values, we transform them into none, and then we transform that into a dictionary. We know that the dataset size is going to be 131 rows, remember from before. And what we do is we basically just send the payload data, okay, this one here, to the API if it's running, to the predict endpoint. So this is the full path to the predict endpoint. Okay, localhost port 8001. This is the port number we're going to be working on. API/v1/predict. Now this is done using the Python requests package. If you wish to use it immediately, it's fine. And then you get the response, and now you can check the status code. So make sure it's 200. The API is up and running. It's making predictions, and then you can
get the JSON part, and because remember it's a dictionary, and now you can get the field called predictions to get the predictions. It's a list of predictions. Okay, data there is of type float. You don't have any errors. The length of the predictions is the same as the expected length of or number of predictions, and then the accuracy is more than 70%. Okay, just a simple test to make sure that our API can make predictions. It can return the predicted values, and we can deal with them. Okay, this is again how to professionally create an API using FastAPI, and I'm sure if any of you have used Django or Flask, the process there is much more complex than this. Okay, now we're ready. Let me go back to Tox and how to run everything. You can run Tox and it'll run the test for you and everything. But if you see in one of the environments here, what have I prepared? Yeah, I have a prepared environment called run. And the run environment does nothing but, it'll prepare some dependencies and then run the main.api script, which is this one, which is the main script. And in the main script, we have this main part here that runs the UV core and using port 8001. So we can do it manually or we can do it via Tox. So let me go to Tox. Clear my screen. And inside the API folder, I'm going to say Tox-E run. Remember, it's this environment, okay? It's this part of it. This part, the run environment. If you do Tox only, remember, it run all these environments for you, 4 of them. I did not include run there. Okay? So let's say Tox-E run, hit enter. Should not take too long because, like I said, in my case, I have already run Tox before to save some time. Otherwise, it takes several minutes. See, now it's running the command python app/main.py. Should not take too long, and our friend should be up and running. Give it a few moments. There you go, UV core is up and running. And it's telling you it's up running under this path. So let me copy this, go to my web browser, paste it in here, and there you go. So welcome to the API. So to access the docs, you can click here. And now remember we have the health endpoint and the predict endpoint. The predict endpoint expects the post method style, and the health endpoint is a get. So if you click there, okay, it'll give you data that looks like this. Okay, if you want to try it, and you can't try it, execute. And yeah, it'll give you a response that looks like this. That's the name of our API, Titanic Survival Prediction API. And this is again something in the configuration. Okay. One second. I seem to have forgotten where I've configured this. Where did I configure this API name? Not here. Goodness me, I need some coffee. But anyway, that's the configuration somewhere inside our file, inside our API configuration. And in fact, okay, this is the path where you can find the endpoints. Okay, let's try and find where I have specified that name. Where have we specified that name? Am I tired? Okay, can anyone find it? Okay, let me see if you're not. If you haven't fallen asleep, try and find into the code and let me know where it is. Okay, let's have this as a bit of homework. Okay, but let's continue with the testing, because that's where we will see the real world application. Okay, that's where we'll see the actual stuff and how to actually use it. That's the API version 0.0.1, and that's my model version 0.0.10. Yeah, that's read from the actual Python package, the Titanic survival prediction package we created earlier on. Okay, it's read from there on the fly. Now I'm going to go back, and then I'm going to go to the predict endpoint. Remember, this stuff is coming for free, built in because of Swagger, the Open API standard. So the predict endpoint, remember the schema we created and the example we created, we mentioned before, which is this one. Where is the schema? Predict. So we have it here. This is the example I mentioned before, and now it comes by default as default data within the predict endpoint. Just in case you want to try, so you can try it out. So this is your data. We have 3 entries here. I'm going to say execute, and this data will be sent to the API, to the predict endpoint, and it return prediction. So that's the response. And remember, we said it's a dictionary, 3 parts: error null, the version 0.0.10, and these are the 3 predictions: 0, 0, class 0, class 0, class 0 for these 3 guys. Now let's try and play with it. For example, age is meant to be an integer, right? So if I change this into a string, or between quotes, and say, for example, x444, try and execute, and now it says, we have an error there, unprocessable entity. Why? It's because it's expecting that field to be of type integer. See, for the first entry. The second entry is fine. The third entry is fine. See, this is fine. This is fine. The first entry, which is this, is saying, I cannot process that. Remember the schema and the data type and pedantic. This is where it's extremely useful. Okay. In fact, if you dig deeper, see now it says here, yeah, something should not see. It's a variable called age. Value is not a valid integer. This is beautiful stuff. It's telling you the variable called age should be of type integer. Type error, it should be integer. A very specific to the point to where the problem is. Right. I hope you like this stuff. It's specifying with types. Okay, so I'm going to stop here. That's how you create the API.